Good morning, students. Let us discuss today's class. Okay, collision theory. Today we discuss about collision theory. Collision theory: reactant molecules collide with each other to form transition state or activated state and immediately give product. Okay, so here collision theory, we are discussing about collision theory. Collision theory tells about rate how the reactant is converting into product. Okay, it doesn't tell about the feasibility of reaction. Okay, so we are discussing about collision theory. So before this, in this chapter, chemical kinetics chapter, we discussed about order of reaction, differences between order of reaction and molecularity. Okay, we also discussed about integrated rate equations, half-life period. Next, today we discuss about collision theory. Reactant molecules collide with each other to form transition state or activated state and convert into product. So whatever the chemical reaction, even in every chemical reaction, the reactant molecules collide with each other. Reactant molecules. So these are reactant. Assume that A is a reactant and it is converting into product. Now what happens? These reactant molecules are assumed to be hard spheres. So these reactant molecules collide with each other and converted into activated molecule. So these activated molecules, when collide with each other, these activated molecules collide with each other, they converted into which one? Product. Okay, so this is which molecule? Activated molecule converted into which one? What a product. Activated molecule is converted into which one? Product. So reactant molecules are assumed to be hard spheres. So here transition state is formed here. Transition state is formed in the reaction. So this transition state, after converting into transition state, that reactant molecule is converted into which one? Product. Okay, here it is given here. The reaction is taking place in between hydrogen and I2. H2 plus I2 molecules are given. They are converting into 2Hi. Okay, so this is hydrogen molecule. Okay, this is iodine molecule. Hydrogen molecule and iodine molecule. And both collide with each other and converted into this activated complex. Activated complex is formed in the reaction, and activated complex is converted into hydrogen iodide. Product is formed in the reaction. So product is formed in the reaction. So activation energy. What is activation energy? The minimum energy required by molecules of reactant to cross energy barrier, means the sufficient minimum energy that is required by a reactant molecules to convert into product. So before converting into product, the activated molecule must cross energy barrier. So what is energy barrier? We will see here. Okay, so this is the graph for exothermic reaction, and this is a graph for endothermic reaction. Exothermic reaction means heat is evolved in the reaction. Heat is released in the reaction. Endothermic reaction means heat is absorbed in the reaction. Exothermic reaction and endothermic reaction. So delta H is equal to क्या है बेटा? Negative. Delta H is equal to positive. Delta H is equal to negative means heat is released in the reaction. Delta H is equal to positive means heat is absorbed in the reaction. Okay, so this is the graph between potential energy versus progress of reaction. Okay, so this is ER means what here? Energy of reactant molecules. So this is energy of reactant molecules. Okay, from here to here, this is energy of potential energy. We also call it as potential energy of reactant molecules. And this one is potential energy of product. This is potential energy of what? Reactant. This is potential energy of product. Okay, now here reactant are present. Here this is what? Reactant is present, and here which one is present? Product is present. reactant and product is present here. Okay. Now ER it is given potential energy of reactant. EP means potential energy of product. Okay. Now this reactant molecule is causing this barrier. This one is called as energy barrier. This is called as energy barrier. Energy barrier. This is called as energy barrier. Energy bar. Reactant molecule is converting into which one? Product. And reactant molecule is crossing which one? Energy barrier. So the energy required, this one from here to here, the energy required to cross the energy barrier is called as EA. EA for which reaction? Forward reaction. It is EA of which reaction? Forward reaction. So here to here, this is called as activation energy required for which reaction? Forward reaction. This one is called as activation energy required for product, conversion of reactant into product, means a forward reaction. So here two reactions will be there. Suppose A gives rise P and P gives rise A. So forward reaction will be there as well as backward reaction will be there. Forward reaction and backward reaction. So activation energy for forward reaction, this one. This difference is called as activation energy of which reaction? Forward reaction. And the energy required from here to here, this is called as threshold energy. This is called as which one? Threshold energy. Here to here, the energy from here to here, this is called as which energy? Threshold energy. Threshold energy. Okay. So threshold energy. How we get threshold energy? Threshold energy is equal to the potential energy of reactant plus activation energy of product. How we get activation energy of forward reaction? So activation energy of forward reaction is calculated by, how we calculate enthalpy of activation threshold energy minus potential energy of reactant. By using this formula we can calculate activation energy for which reaction? Forward reaction. Activation energy for which reaction? Forward reaction. Activation energy of forward reaction, this is F. F means here forward reaction. So activation energy of forward reaction can be calculated by threshold energy minus potential energy of reactant. Here to here, potential energy of reactant. Here to here, threshold energy. If threshold energy minus potential energy of reactant is made, then we will get which one? Activation energy of forward reaction. Activation energy of which reaction? Forward reaction. And here one more given here. Here, so here you can observe here this is the energy difference. Activation energy of B means what here? Backward reaction. Activation energy of which reaction? Backward reaction. Now here product is there, so here to here this difference is called as potential energy of product. It is called as EP means what here? Potential energy of product. And here to here, this is called as potential energy of which reaction? Backward reaction. So what is threshold energy? Threshold energy means the energy required to pass this energy barrier. Okay. So threshold energy, if we subtract, activation energy of backward reaction can be calculated by threshold energy minus potential energy of product. Potential energy of product. Threshold energy is equal to potential energy of product. So this is activation energy of forward reaction. This is activation energy of backward reaction. Okay. So any activation energy of forward reaction is equal to threshold energy minus potential energy of reactant. Okay. Activation energy of backward reaction can be given by threshold energy minus potential energy of product. Okay. Now how we calculate enthalpy of reaction? Delta H means enthalpy of reaction. Enthalpy of reaction is equal to potential energy of product minus potential energy of reactant. Potential energy of product minus potential energy of reactant. So here EP minus ER. EP minus ER will give enthalpy of reaction. So if we substitute this one, EP is smaller, ER is larger, that's why we will get which one? Delta H will be negative. So delta H will be negative means which reaction? It is exothermic reaction and heat is released in the reaction. So heat is released means which reaction it is? Exothermic reaction. It is which reaction? Exothermic reaction. Exothermic reaction. Exothermic reaction. Exothermic reaction. Exothermic reaction. This is which reaction? Exothermic reaction. Heat is absorbed means it is endothermic reaction. Exothermic reaction and endothermic reaction. So heat is absorbed means endothermic reaction. Heat is released means heat is absorbed. Heat is absorbed means endothermic reaction. Heat is released means which reaction? Exothermic reaction. So this is the graph for which reaction? Exothermic reaction. Now here you can observe. This is what? EP. EP means what? Potential energy of product. So this is what here? This is up to here to here. This is potential energy of reactant. So product potential energy is higher. Reactant potential energy is smaller. So difference will become positive. So enthalpy of reaction is equal to how we calculate potential energy of reactant minus potential energy of product minus potential energy of reactant. So here potential energy of product is greater than potential energy of reactant. Then it is delta H will be what? Positive. So delta H is equal to positive means which reaction? It is endothermic reaction. So this is for endothermic reaction, and this is for which reaction? Exothermic reaction. So this is the graph for exothermic reaction, and this is the graph for which reaction? Endothermic reaction. Okay. So this is how we calculate activation energy. So activation energy also we calculated it. Activation energy of forward reaction is equal to threshold energy minus potential energy of reactant. Okay, and activation energy of backward reaction is equal to threshold energy minus potential energy of product. Potential energy of product. Okay. This is about which one? Collision theory. Now here it is clearly given. Here enthalpy of reaction delta H is equal to enthalpy of product minus enthalpy of reactant. Delta H is equal to enthalpy of, this is one another formula. Enthalpy delta H is equal to activation energy of forward reaction minus activation energy of backward reaction. Activation energy of forward reaction minus activation energy of backward reaction. One more formula is also given here. Threshold energy. How we calculate threshold energy? Activation energy of forward reaction plus potential energy of reactant. Then we will get threshold energy. Or else another formula is also there. Another formula. What is another formula? Activation energy of backward reaction plus potential energy of product. Potential energy of product. So this is also like this. Also we can calculate enthalpy. Threshold energy can be calculated like this. Okay. Next, product plus in the potential energy of product minus activation energy of which reaction? Backward reaction. So Arrhenius equation. Next, the rate constant for most of the reactions increases with increase in temperature. This is very important one. So as we discussed in the last class, effect of temperature we discussed. Activation energy, relation between activation energy and rate constant temperature can be expressed by using this equation. Okay, Arrhenius equation. So according to Arrhenius equation, we can say that as the temperature increases, rate constant value increases. Rate of reaction also increases. So rate of reaction get doubled or tripled on 10 degrees rise in temperature. For each 10 degree rise in temperature, rate of reaction get doubled. In some of the reaction, rate of reaction may tripled also. Okay. Now Arrhenius equation. What is Arrhenius equation? K is equal to A e power minus EA by RT. K A into e power minus EA by RT. So here A means what here? A means Arrhenius constant. Arrhenius constant. R means what here? Gas constant. T means what here? Temperature. T means what here? Temperature. And EA, what is EA beta? EA means activation energy. Activation energy. Okay, so by plotting the graph log k versus log a minus EA by RT. So if we take the graph here, okay, if we calculate, if we take the graph here, so graph can be like given like this. So here this equation, okay, so what I wrote here, k is equal to a e power minus EA by RT on taking log both sides. Log k is equal to natural logarithm, log k is equal to log a minus EA upon RT, EA upon RT. Okay, here log k, if suppose base 10, log base 10 is given, log k is equal to log 10a minus EA by 2.303 RT, 2.303 RT. Okay, if suppose if we take the graph, if you plot a graph between log 10k versus 1 by T temperature, and we will get like this. Okay, so this graph is in the presence of y is equal to mx minus c. So here mx means what here, 1 by T. This is 1 by T, we can write it as 1 by T. 1 by T equal to which one, x. EA by 2.303 R indicates m, and this is log c. Okay, intercept is log c, and slope is equal to m, slope is equal to minus EA by 2.303 R. So negative slope, that's why the graph is like this. Negative slope graph will be like this. Okay, so by plotting log k versus 1 by T, activation energy can be determined. With the help of graph also we can determine activation energy. We can determine which one, activation energy, with the help of graph. Okay, so very very important this one. So slope is equal to which one, slope is equal to minus EA by 2.303 R. If you plot a graph between log k versus 1 by T. Okay, next, as temperature coefficient. What is temperature coefficient? With every 10 degrees Celsius rise in temperature, rate of reaction either gets doubled or tripled, or between them, that is 2 greater than less than or equal to or T degree Celsius plus 10 degrees Celsius by RT less than or equal to 3, means temperature coefficient mu will be equal to 2 to 3. Okay, so this is effect of temperature. Okay, so this is about which one, chemical kinetics. Now you can see here, these are the problems. Okay, so we'll discuss problem here. So for a hypothetical reaction is given here. Hypothetical reaction 2A gives rise 3C. The rate of reaction rate are in terms of the rate of change in the concentration of reactant can be given by. So here equation, what is equation here? 2A gives rise 3C is given. So rate of change in the concentration of reactant. Change in the concentration of, as the reaction progresses, rate of reaction what happens, decreases or increases? Sorry, as the reaction progresses, concentration of reactant what happens, decreases, and the concentration of product what happens, increases. So if we want to express rate of reaction by using reactant, we will use which symbol, negative sign here, and in case of product we use which sign, positive sign. So if you write rate expression here, rate of reaction equation here, so what it becomes, in case of reactant minus 1 by 2 dA by dt in case of reactant. In case of product what it becomes, plus 1 by 3 dC by dt. Okay, so among these two, which one is correct here? This is according to which one? Reactant. This is according to which one? Product. Okay, so here the question in question are in terms of the rate of change of the concentration of reactant. So concentration of reactant means minus 1 by 2 dA by dt. So which option? Second option. Okay. Next, if we come here, the rate of the order of reaction can be determined from. So order of reaction can be determined from which one? Chemical equation, experiment, rate of disappearance of reactant, thermochemical equation. So rate of reaction, order of reaction is determined by using which one? Experiment. Okay. Next question, if you see this one, the inversion of cane sugar represented by C12H22O11 plus H2O gives rise C6H12O6 plus C6H12O6 is a which type of reaction? Okay, so this reaction here, what happens? How many reactants are there here? Two reactants are there. C12H22O11 plus H2O gives rise C6H12O6 plus C6H12O6. This is sucrose, this is glucose, and this is which one? Fructose. Here in this reaction, if you take this, we can write it as rate is directly proportional to concentration of C12H22O11 and concentration of H2O. But this reaction, in this reaction what happens? This is the inversion of cane sugar reaction is there. So in this reaction, throughout the completion of reaction, the concentration of water remains constant. Concentration of water remains constant. Concentration of water remains constant. Because how we can make it? By taking concentration water in excess amount. If any one of the reactant is taken in excess amount, then we can assume this, the concentration of water remain constant. So in that case, rate will automatically depend upon which one? Concentration of another reactant, that is sucrose here. So here among these two, rate of reaction is directly depend upon the concentration of which one? Reactant only. It won't depend upon the concentration of water, only sucrose concentration. So this reaction is appearing like second order reaction, but it is which reaction? First order reaction. So order is 2, but molecularity is 1. This type of reactions are called as pseudo first order reaction. Pseudo first order reaction. So it is which reaction? Pseudo first order reaction. So inversion of cane sugar and hydrolysis of ester. Hydrolysis of ester, CH3 COO C2H5 plus H2O gives rise in acidic medium, gives rise which one? CH3 COOH plus C2H5OH. Here rate of reaction is directly proportional to concentration of ester. Rate is directly proportional to concentration of ester. So this type of reactions are called as pseudo first order reactions. These are called as which one? Pseudo first order reaction. Okay, next for the reaction A plus B products, it is found that order of A is 2 and order of B is 3 in the rate expression. When the concentration of both A and B doubled, then the rate will increase by a factor. Okay, so here the reaction is given as A plus B gives rise P product is given. Okay, now if we write the equation, R1 is equal to K A power, order with respect to A is 2 and order B with respect to B is 3. With respect to A is 2 and with respect to B is 3. Okay, this is the rate expression, rate law expression. Now what we did here, when the concentration of both A and B are doubled, rate increases by. So in that case R2 is equal to rate will get doubled or triple, we have to see. So what we did here, concentration of A is doubled. Concentration of A doubled means A 2A square, and concentration of B also doubled. B also doubled means doubled. Doubled means 2B power 3. 2B power 3. Okay, A and B both get doubled. Now this is equation 1, this is equation 2. So 2 by 1, if you make 2 by 1, so what it becomes, R2 by R1 is equal to, what it becomes, K 2A square 2B power 3 by K A power 2 B power 3. B power 3 cancel, A power 2 cancel, A power 2 K cancel. Okay, now R2 by R1 is equal to 2 square remain, 2 square here 2 power 3. So 2 square means how much, 4. 2 power 3 means 8. Okay, so what it becomes, 4 into 8, how much here, 32 times. So R2 is equal to 32 times of R1. Okay, so what we did here, we wrote equations here. So here for the reaction A plus B products, it is found that order of A is 2 and order of B is 3 in the rate expression. When the concentration of both A and B doubled, then the rate will increases by a factor. This is the question. So what it becomes here, if we say here, first we have to write the rate expression according to the data given in the problem. So R1 is equal to K A power 2 and B power 3. This is equation 1. R2 is equal to K 2A square 2B power 3. This is equation 2. Because concentration of A and B both get doubled. So equation 2 divided by 1. Then R2 by R1 is equal to K 2A square 2B power 3 by K A square B power 3. Okay, so K cancel, A square cancel, B power 3 cancel. In that case, what it becomes, R2 by R1 is equal to 2 square and 2 power 3. So 4 into 8, how many times? 32 times. So R2 is equal to 32 times of R1. R2 is equal to 32 times of which one? R1. Okay. So which option here? 32 times, which option here? Which option? This one. Now the unit of rate constant for the following reaction. PCl5 gives rise PCl3 plus Cl2. Here PCl5 gives rise PCl3 plus Cl2, and it is which reaction? Elementary reaction. Elementary reaction, we can write coefficient in order. So rate is equal to K PCl5 power 1. So PCl5 power 1 means which reaction? First order reaction. So for first order reaction, what is the unit of rate constant here? Unit of rate constant for first order reaction, the rate constant unit is second inverse. So which option? First option. First option. Okay. Okay. So this is about which one? Chemical kinetics chapter. Okay. So in the next class we discuss next chapter. Okay. Thank you.